Hi, grade 9. So today we're starting chapter 6, which is a little different from the chapter that we just finished. And it's going to be more like scatter plots and plotting data and talking about continuous and discrete data. So I think it will be easier for many of you. So I hope you appreciate that. There's a handout on Teams that you should fill in as you watch this video. So lesson 6.1, interpreting data. At the top of your handout there, it says continuous versus discrete. So we've talked about these terms before, and we're just going to review them again. So a variable is continuous if any value between two plotted points is possible, so these are the blanks, possible and meaningful. So what that means is if my variable is time and the points that I've plotted are 1 minute and 2 minutes, then any value between 1 and 2 minutes is possible and meaningful. So I can have a minute 15 seconds, I can have a minute 30 seconds. They don't have to be whole minutes. So this is continuous data because anything between those 2 points is also possible and meaningful. Now, if my variable is discrete, that means if values between two plotted points are not possible or meaningful. So same blanks there. And that's like if we're talking about the number of people, if I have on my graph, I have 5 people and I have 6 people, well, between those 2 points, between 5 and 6, I don't have 5 1/4 people, right? We only talk about people in terms of wholes. So there's 1 person or 2 or 3, there's not 1 1/4, 1 1/2. So that's discrete because we're not talking about all the decimals between them. So on a graph, we use a solid line to connect the dots if both variables are continuous. So if we're talking about those decimal numbers between the points, then we would connect it with a solid line. We would connect with a dotted line if one or both variables are discrete. So to use a solid line, both have to be continuous, but if one of them is discrete, you'll connect them with a dotted line. Next, we're talking about independent versus dependent variables. So the independent variable is x. And on your graph, that's this one here. This is x. And the variable doesn't depend on the other variable. So the blank there is depend. For example, if we're talking about the height of a tree over time, the time doesn't depend on how tall the tree is. Right? The time is what stands by itself. And then the dependent variable is y, and that's the vertical, the vertical. And the blank there, the variable depends on the independent variable. So using that same example, the height of the tree depends on the time, right? Or the age of the tree. So the time doesn't depend on the height, but the height depends on how long the tree has been growing there. It'll be taller if it's been growing for a longer time. Next, there are 3 things that a graph needs. So you'll be drawing quite a few graphs in this chapter. So make sure you always have these 3 things. The first thing that you need is a title. Always have a title. The second thing are axes labels. So that is, you need to label both of the axes, X and Y. And the third thing is appropriate scales. So make sure that you go up by a number that makes sense so that if you have your graph, it's not just all down here, but that it fills the space well and that you have enough room for the data. All right, so let's do an example using this stuff that we just talked about. So there's a table there on your handout, and it says the table below shows how many sit-ups Samantha did in gym class. So we have time in minutes, and that's a half, 1, 1 1/2, 2, etc. And then the number of sit-ups that she did over time. So after half a minute, she did 17. After 1 minute, she had done 33. After a minute and a half, she had done 48, and so on. So draw a scatter plot of this scenario, and then describe the relationship between time and the number of sit-ups she completed. So first, let's take down some information about this data. So the independent variable here would be time. And I'm going to tell you this right now, that most of the time when we talk about if one of our variables is time, it's going to be independent. Okay, so it's not often that time is dependent on the other variable. So as soon as you see time, you should think it's X, it's independent. And then the dependent variable is going to be the number of sit-ups she completed, because how many sit-ups she did depends on how long she was doing it for, right? If someone says to you, how many sit-ups can you do? Then you might say, it depends how long I have to do them, how much time you give me, right? Okay, and on to the second page there. Is this data discrete or continuous? So we can look at time, and time you can have parts of a minute, so that would be continuous. But then if we look at the number of sit-ups she did, we're not counting if she did 1/8 of a sit-up. We're only counting how many whole sit-ups she did. So and that's discrete, so because one of the variables is discrete, we call this whole thing discrete. Okay, so that's that blank there. So this is discrete data. So that means I'm going to connect the dots using a dotted line. That's the next blank. The scale on the x-axis, so we have minutes here. If you look at the chart, we're going up by half a minute. So in order to spread this out on our graph nicely, let's go up by 1/4 of a minute, so 0.25, and we should go up to, let's say, 4.5. Because our chart goes up to 4, so to give a little bit extra room, let's go up to 4.5. And then on the y-axis, let's go up by 5s. And the highest number in the chart is 91, so let's just go up to 100. Okay, so let's make our graph here. I'm just going to draw this. Start by giving your graph a title. So a good title for this one would be number of sit-ups Samantha completed. Oops, I didn't spell Samantha correctly. Samantha completed. All right, and then let's label our axes. So we said time was independent, which means it's X. So this down here is going to be the time in minutes. And you'll notice that I didn't draw my graph like this as a coordinate grid because I don't need those negative sections. She's not doing -10 sit-ups and she's not doing -10 minutes. So I only need the positive sections, which is why I'm doing my graph like this, just with an X and Y axis. And then my Y axis is going to be sit-ups completed. All right, and then go up by quarters. So 1/4, 1/2, 3/4, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. And then here I'm going to go up to 100. Not sure if mine's going to fit. 10, 20, 30, 40, 50, 60, 70, 80. Okay, mine doesn't fit, but yours does. I checked. So mine only went up to 90. But now I'm going to plot the points. So after half a minute, she had done 17 sit-ups. After 1 minute, she had done 33. After 1.5 minutes, she had done 48. 2 minutes, 62. 2.5 minutes, 72. 3 minutes, 80. 3.5 minutes, 86. And 4 minutes, 91. Right up here somewhere. Right? So now, how did we say we were going to connect this? Let's look back. We said we were going to use a dotted line because this is discrete. So we're going to start here and connect this with a smooth line. And that is how many sit-ups she did. So let's talk about the relationship between the time and sit-ups. So she's going up at a pretty consistent rate here. And then it starts to curve, which means it slows down. So that's probably just because she's getting tired, right? After 4 minutes of sit-ups, you're going to be getting tired and doing less in a minute. So let's write that down. Going up at a consistent rate at first, and then slowing down at the end. She's probably tired. All right, so that's kind of the route you need to take when you're approaching one of these questions. Your homework there is page 327, number 4, 7, and 8, and I need you to hand in number 7. So this is new. You're going to be handing in 1 or 2 questions from your homework, and I'm going to be marking it. So make sure that you submit that on Teams, and just let me know if you have any questions.